Hi everyone, so today we're going to be talking about how to solve quadratics by factoring. When we factor, it splits up the x's into two separate chunks, and then we can solve those chunks using what we know. The way that they are currently laid out on your example sheet, you can't solve them, so we've got to split them up and then solve. And the way that we split them up is with something called factoring, so let me show you how to do that. The first example is x squared plus 7x plus 10 equals 0. Now, here's the deal. I'm going to show you, there's a couple of different ways to factor. I'm going to show you the easiest way that I think there is, and it's called the box method. So in the box method, we're going to draw a big box, and inside the box, we're going to have 4 separate boxes. And this is how all of these are going to go. And we always put the first chunk up in the top left box and the very last chunk in the bottom right box. Again, how it always goes. Now, the goal is to multiply to find two numbers that multiply to be whatever the first chunk times the last chunk is. So in this case, the first chunk times the last chunk is 10 times x squared, which is 10x squared. And then we also want to find two numbers that add to be the middle number, 7x. So that's how it always goes. We want to multiply to be the first times the last number, and then add to be the middle number. And when I talk about multiplying and adding, we're finding two numbers that do that. And so the easiest way for me to do that is to think about numbers that multiply to be the multiply number. So we want to multiply to be 10. I know it says 10x squared. We're just going to focus on the number for now. So we're going to think about all the numbers that multiply to be 10. Well, we know that 1 times 10 multiplies to be 10. And we also know that 2 times 5 multiplies to be 10. So those are my factors of 10. And now we've got to figure out of those, which ones would add to be 7. So 1 and 10 give me 11, right? And 2 and 5 give me 7. So that works. So 2 times 5 is the thing that works for us. And in order for it to multiply to be 10x squared and add to be 7x, it would have to be 2x times 5x. Because 2x times 5x gives me a 10x squared, and a 2x plus 5x gives me a 7x. And so what we're going to do is we're going to put a 2x up here and a 5x down here. We're basically going to fill in those other boxes. And it doesn't matter. We could have put the 5x on the top box and the 2x on the bottom box. That part doesn't matter as long as you fill in those last two boxes with what multiplies to be 10x squared and adds to be 7x. Okay, so now that the box is all filled up, what we're going to do is actually factor the box. And the way that we're going to do that is we're going to say, well, what do the 5x and the 10x have in, or sorry, the 5x and the 10 have in common? Or another way to say that is, what can I divide those two things by? What can I divide 5x and 10 by? Well, if I think about it, I can divide those both by 5. And so what I'm going to do is draw that 5 on the outside of the box. Now I'm going to do the same thing, but to the top two boxes. So what do the x squared and the 2x have in common? There's not a number that they have in common, but they both have an x. So what I'm going to do is draw an x on the outside of the box. Now we're going to do the same thing, but we're going to do it to the left two boxes. So what do the x squared and the 5x have in common? Once again, they don't have a number in common, but they do have an x in common. So I'm going to draw an x on the outside. And then what do the right two boxes have in common? We have a 2x and a 10. In this case, the better way to ask it is, what can I divide both of those things by? And the highest thing that I can divide, the biggest number I can divide them both by is a 2. And so the things on the outside, this x and 5 and x and 2, are actually my factors. And so what that means is I can write it out like this: x plus 5 from the side and x plus 2 from the top. Now, this x plus 5, x plus 2 is just another way to write my original equation, which is the x squared plus 7x plus 10. And so that's equal to 0, just like that x squared plus 7x plus 10 was equal to 0. So this is how we factor. That's great. That's the hardest part. Now that we have it factored, what we're going to do is actually separate the factors and set them both equal to 0. So I can say x plus 5 equals 0 and x plus 2 equals 0. Then I'm going to solve both of those for x. To solve the x plus 5 for 0, I'm going to subtract 5 from each side. So we get x is equal to negative 5. And then the same thing with the x plus 2, I'm going to subtract 2 from each side, and I get x is equal to negative 2. So my two answers are x equals negative 5 and x equals negative 2. Those are my solutions to this equation. All right, let's try it again. And like I said, we're gonna use the box method for all of these. So example 2 is x squared minus 5x minus 36 is equal to 0. So once again, we want to separate those into two separate chunks or two separate factors that separate the x's, and so we're going to do that with that box method. So we're drawing a box with 4 boxes inside. We put the first chunk in the top left box, the very last chunk in the bottom right box, and you have to keep the sign with it. So because it's a negative 36 in the back, we're going to keep it negative. Now we're going to find two numbers that multiply to be the first times the last number, which would give me a negative 36x squared, and then add to be the middle number, which is negative 5x. So, like we did the last time, we're going to think about factors of 36, or what can multiply to be 36. So we know that 1 times 36 is 36. We know 2 times 18, 3 times 12, 4 times 9. And I think those are all of the factors of 36. So now we're going to go through those options and figure out which one could potentially give me negative 5. Now this, it gets a little bit different than that first example, because on that first example we were just adding those numbers. In this case, I can tell you that adding these numbers together will never give me a negative 5, but we can change some of them to be positive or negative. So let me show you this. I'm going to tell you the answer is the bottom one, the 4 times 9, but in order to make it a negative 5, what I would have to do is make the 9 a negative. So what if I did 4 times negative 9? Well, 4 times negative 9 gives me negative 36, which is great because that's what we wanted. We wanted it to be negative 36. And then we know that 4 plus negative 9 is a negative 5, which is what we wanted it to add to be. So with these signs, you can change them between positives and negatives, but you still need to make sure that they multiply and add to be the right numbers. So if it has to multiply to be a positive, then we want to make sure that our numbers, no matter what we change the signs to be, still multiply to be a positive. Same thing with the adding. If it has to add to be a negative, great, just make sure that your numbers are set up in that way, or the signs are set up in that way, that when you add those two numbers, they end up being negative or positive or whatever you need. Okay, so we know it's 4 and negative 9. What I'm going to do is write a 4x on one of the boxes and a negative 9x in the other box. All right, and then we're going to go through and factor these boxes. So what do the bottom two boxes have in common? Well, they both have negatives, so I'm going to pull a negative out. And then they are both divisible by 9 as well. Now the top two boxes, they don't have numbers in common, but they do have x's in common. And then the left two boxes, once again, have those x's in common. And then the right two boxes have a 4 in common. Now, this gets a little bit tricky because 36 is negative, but we don't pull a negative out. The only time you pull a negative out is when the parts with just one x are negative. So then we pulled a negative 9 out because the 9 was negative, but we pulled a positive 4 out because the 4 was positive. Okay, so now my factors are on the outsides, x minus 9 and x plus 4 equals 0. Now that we have it in factored form, which is like when we split the x's up, we can actually set them both equal to 0. So x minus 9 equals 0, x plus 4 equals 0, and we can solve both of those by adding 9, and we get x is equal to 9, and then subtracting 4. X equals negative 4. So my two answers are x is equal to negative 4 and to 9. All right. Let's do it again. This one's a little bit different. So the third example says 3x squared minus 13x minus 30 equals 0. Now, on this one, even though they have, well, the big thing about this one, or the big difference in this one, is that there's a number in front of the x squared. We're still going to do it the exact same way with that box method. It just might get a little bit more complicated because that number is in the front. So first chunk goes up here, that chunk goes down here. We want to multiply to be the first chunk times the last chunk, which in this case would give me negative 90x squared, because 3 times negative 30 is negative 90. And then we want to add always still to be the middle chunk, so negative 13. All right. Oh, negative 13x, I'm sorry. Okay, so once again, we're going to start with the thing we have to multiply by and find two numbers, or find all the factors, all the things that could potentially make that happen. So we could have 1 times 90, 2 times 45, 3 times 30, let's see, 5 times, let me think about that, 18, and then 10 times 9. Okay, so now what one of these could add to be negative 13? You can kind of look at it, but because 13 is a smaller number, we're going to maybe look down at the bottom portions, either of these two, because they're closer together. I'm going to tell you it's this 5 times 18, but in order to make it a negative 13, the 18 needs to be negative. So let's just double check. 5 times negative 18 gives me a negative 90, and 5 plus a negative 18 gives me a negative 13. Which is great. That's exactly what we want. So what I'm going to do is put a 5x in one of my boxes and a negative 13x in another box. Or sorry, not a 13, 18x in another box. Okay, so now, once again, what do the bottom two things have in common? Or what can I divide them both by? They are both divisible by negative 6. In this case, normally we just pull the number out that's in front of the x, but you can't do 30 divided by 18 and get a whole number, so you have to think, what do they both have in common, or what can I divide both of them by and still get a whole number? In that case, it's negative 6. Now, what do the top two boxes have in common? They just have an x in common. The 3 and the 5, they don't have anything in common. And then on the left two boxes, we know we have an x in common, but the 3 and the 18 also are both divisible by 3, so that's a 3x in common this time. And then the right two boxes have a 5 in common. And so my factors are x minus 6 from the side and 3x plus 5 from the top. So now that we've got these x's separated, we can separate them and set them both equal to 0. X minus 6 is equal to 0. 3x plus 5 is equal to 0. And then solve them both by adding 6. We get x is equal to 6. And then subtracting 5 from each side would give me 3x is equal to negative 5. Divide each side by 3, we get x is equal to negative 5 over 3. So our two answers are x is equal to negative 5 over 3 and x is equal to 6. All right. Okay, one more. Once again, we're going to use the box method on this. So it's 8x squared plus 32 is equal to 0. Now, this one is a little bit interesting. There's not a term with just one x. And so the first thing I'm going to show you is we're going to come back to that term with an x, but the first thing I'm going to show you is that these both are divisible by 8. So I can actually rewrite this as 8 times x squared plus 4. And then from there, what we can do is, and then set that equal to 0. Oh, you know what? I'm sorry, this should be a minus. That was my screw up. Let's change that to be a minus. Okay, now, from there, I can actually write it with that x term, with the x term, but there is no x, right? So what I can do is say plus 0x and then minus 4 equals 0. This is the same thing as writing what I wrote above it. It's just that it has that x term, and that'll be helpful when we do the box method. So now let's start the box method. And in the box method, we're going to kind of forget about the 8 that I pulled out. And the reason why is because that 8 doesn't have an x on it. We'll come back to it and we'll put it in our kind of help solve for our final answer. But in this case, we're just focused on the stuff that's inside the parentheses. So the x squared is going to go up here. The negative 4 is going to go down here. I want to multiply to be negative 4 times x squared, which would be negative 4x squared, and then add to be the middle term, which would be 0, x. All right, so now let's think about all the numbers that multiply to be negative 4. We've got 4 times 1, and then 2 times 2. Those are my two options. Now, the things that are going to add to be 0 are the 2 and the 2. But in order to add to be 0, I need one of them to be negative. So negative 2 times positive 2 gives me a negative 4. Negative 2 plus 2 gives me a 0, which is exactly what we want. Especially when you're trying to add to be 0, you want to make sure that you have the same number. So like a positive and a negative version of the same number. Okay, so now we're going to put a negative 2x in one of the boxes, positive 2x in another box, and then once again, what do the bottom two numbers have in common? They have a 2 in common. What do the top two numbers have in common? They have an x. Left two numbers have an x, and right two numbers have a negative 2. So when I write this out, I'm going to have the 8 from up top, and then x plus 2 from the side, x minus 2 equals 0. Then that 8, here's the deal. We could potentially take this whole equation and divide each side by 8. And then the 8's cancel out on this side, and we're just left with x plus 2, x minus 2. And then on the right side, we'd have 0 divided by 8. Which 0 divided by anything is just 0. So the 8 kind of cancels itself out, but it's good to recognize, oh, I can take that out of the way. Now I can set each chunk equal to 0, so x plus 2 is equal to 0, x minus 2 is equal to 0, and I solve both of those. So I subtract 2, and I get x is equal to negative 2. I add 2, and I get x is equal to positive 2. So my answers are x is equal to negative 2 or positive 2. And there we have it. That's how we solve quadratics by factoring.